Hey guys, how's it going? Today we're going to do page 310 to 311, numbers 13, 27, and 39. The directions for number 13 says to find dy dx. So we're going to look at this and we have an x in the lower limit in this one, not in the upper limit. But that tells us that we're going to use fundamental theorem of calculus part 1. But in order to do that, we have to have the number down on the bottom, the variable up on the top. So the first thing we're going to do is we're going to change the sign and then switch these. This is going to become 6. This is going to become x. And just to save us a little bit of time, we're not going to rewrite the whole thing. Now we take the derivative of both sides, d dx. We know our answer is going to be negative. The derivative of this, these two are canceling each other out basically. We throw our x into there and we get the negative natural log of 1 plus x squared. And we take the derivative of this too, because we're going to use the chain rule. The derivative of x happens to be 1, so we're done. Perfect, easy, nice, no problem. All right, now we're going to move on to this next question, number 27. And 27 says, evaluate each integral using the evaluation part of the fundamental theorem. So this is the fundamental theorem of calculus part 2. So we look at here, we have numbers on the top and we have numbers on the bottom. So we're going to have to take the antiderivative of this. So we go through and we easiest way whenever we have x variables in the denominator is to rewrite using negative exponents. So we got 2 minus x to the negative 1 dx. So we just start going through and we try to find the antiderivative of this. This is going to give us 2x. And then we go here because we take the x to the 0, we add 1, we divide by 1. Now we're going to take this x to the negative 1. We add 1, and we get x to the 0 divided by 0, which we know is undefined. So we can't do that. So we have to think of some other way to do this. So you got to look at all your derivative rules and say, do you ever see anything that has the derivative where the derivative comes out to be 1 over x? So if you remember, the derivative of the natural log of x is always 1 over x. So this one comes up a lot on that AP test, so you guys always got to be looking out for that one. So the antiderivative of 1 over x is just going to be, we use this minus sign, minus the natural log of x, and we're going to use our little notation right there, and we got a 3 and a 1/2. And we're going to plug these in and just continue doing the work. Do our upper limit, 2 times 3 is 6, minus the natural log of 3, minus 2 times 1/2 is 1, minus the natural log of 1/2. And we can go through, we can simplify this a little bit. This is 6 minus 1 is 5, minus the natural log of 3, plus the natural log of 1/2. Now, most of the time, that's going to be your answer. A free response question, you'd be done. You wouldn't want to do anything else. You can punch it in the calculator, get a decimal approximation. Sometimes they may say, oh, 5 minus the natural log of 3. This 1/2 becomes 2 to the negative 1. The exponent comes out in front. Do natural log of 2. But that's going on and doing our rules of natural logs and stuff like that. And so I don't want you to worry too much about that right now. All right, and then our last one, negative 1 to 1, r plus 1 squared dr. So we go to do the antiderivative of this. We do the antiderivative the same way, but this is an r plus 1 squared, and we haven't worked out anything like this. Eventually, we're going to be able to do this and no problem using a thing that we call u substitution. But right now, this is going to give us a chain rule problem. We don't want to worry about that. So the easiest way to do this right now is just to FOIL this thing out. This becomes r squared plus 2r plus 1 dr. So the antiderivative of r squared is r cubed divided by 3 plus 2r squared divided by 2 plus 1r. We're going to plug in 1 and negative 1. 2's cancel out. We get 1/3 plus 1 plus 1 minus negative 1/3 plus 1, because this is r squared, minus 1. Oh, canceling out. We got 1/3 plus 1/3 is 2/3 plus 2, which gives us, that would be 8/3. And that's our answer for this problem. All right, hopefully these examples help you. If you have any questions, please come in, let me know, send me an email, anything you want. All right.